graphing just wanted you to force you to figure out how to change different settings. Okay, so then you had to graph something related to the mortgage. That was the last thing, right? So I have this scenario here, um, and was graphing what as a function of what? So what was the independent variable in the graph that you was looking at, like payment versus interest rate or something, or what was the independent variable that you put on the x-axis? Was it interest
The
rate?
number of payments.
Number of payments? Is it so number of payments, and then and and uh, and what was the dependent variable of what you graphed? Your monthly payment?
The balance
The balance.
after a certain amount of payments.
Oh, so just how your principal balance went down as you paid. Okay, cool. So let's do that for this scenario. So remember last time we were looking at let's see, I'm not sharing my screen. You guys. Okay. So last time we had built this file, and we were looking at the two ways to calculate the payment for this scenario: 0.06 or 6.25% rate, $175,000 principal balance, and 180 months. And so, did we get the same thing for both? No, what's wrong here? Why are these different? Not even close. What did I do wrong here? Is the function right? R over 12 times P, 1 over 1 minus... Who can tell me why this is so far off? Why are these not the same? Yeah, yeah, when it's not italicized like that, when they're non-italicized, that means it's all one thing, yeah. That's bizarre. Did either guys see it? Can you figure out what's wrong with this?
I'm not sure.
Does it look the same? 1.08, 1500.
Is it possible? No, I was about to say, is it possible that like the F isn't in function
Oh, you know
notation
why it
form?
is? You know why it is? Okay, and this is something that's going to come up when you. I know what it is. This is something that's going to come up when you guys are doing your files. Okay? What happened? Look at this. I'm actually glad this happened because this has stumped me and it's stumped many students. Look what I wrote in the first line, right? And then I came down and I wrote this. What happens with this first line? What does that do? It assigns a value to payment, right? Or assigns this formula to payment. And then what does it do with the R, P, and N? Do you remember? Those free variables. Does it make them 1? Is there anywhere else in my file that it's defined R, P, and N? This doesn't. They're just dummy variables here in this function. So I haven't said what R, P, and N are anywhere else in the file. So when it assigns payment, it assigns it with values of 1 for all these free variables. Do you see that? And then I come along and I say, no, just kidding. This is what payment is. But there's no order in GC. GC doesn't do order. So what did it do? Why is it giving me this? Yeah, it's just ignoring this. It did this, and now you can't come along and say, I want to change it now, and leave that one as it is. It's just going to ignore the new definition. Does that make sense, guys? So how do I make this right? How do I make this number right? I want this to be what I want payment to be calculated as. Yeah, just get rid of it, right? So this is what's causing the problem right here. It's calculating payment based on P, N, and R being 1. And this happens as you get in these more complex files. You'll say, if something, then I want payment to be this, and if something else, I want payment to be this. Well, it's just going to ignore it. It's going to ignore it after the first statement. So I'm going to delete that and watch what happens. Are they the same now? Boom, instantly, right? The same. Okay, so we want to graph for this scenario. Let's graph what? I want to graph the principal balance. Oh, is that a different formula though? That's a different formula. Well, so I don't want to write that formula out. So let's just do this. So let's graph. What's something else we could do? Payment as a function of different rates, different principal balance. No, so let's do monthly payment as a function of how many payments, meaning how many payments in the whole loan, right? So in the whole loan. So I want to do that. So how do I graph that? I want to graph what your monthly payment would be as a function of how many payments in the whole loan. So what will I do? So this is just a little extension of what's in your homework. So what should I do? Richard?
Do we have like set values for
Yeah, for these values. For a 6%, 6.25% interest rate, and $175,000 loan, I want to know what my payment will be for different lengths of the loan, right? For say a real short loan or a long loan, etc.
Just type in F of, sorry about that, F of everything except change the 180 with the X.
So everything but except change the 180 with X. And the Y equals, is that right?
Yes.
Okay. What do you guys agree with that? Okay, and so I'm going to graph that. And nothing shows up. I hit enter. Do I have to zoom out? Yeah, so say for a total of 12 or 20 payments, what do you think your payment's going to be? If you had a total of 20 payments on the loan. High or low payment? Super high, right? It's like dividing 175,000 by 20 and adding interest on top of that, right? So yeah, it's going to be much higher. So okay, so I want to zoom. What do I want to do? Zoom out on the y-axis until we get to. If it's one payment, it's going to be something like 175,000, right? What am I looking at here? 5 times 10 to the 6th.
It's 500,000.
Yeah, so you would never have less than one payment. So let's make a good scale here. So how should we restrict the axes? Because you can't have less than one payment, right? Total payment. So what should we put? X is greater than or equal to 1, right? So yeah, so it doesn't make sense to have less than one payment. So X is greater than or equal to 1. And then we can zoom back in on the y-axis. There we go. And so if it's just one payment, what is it? How much is it? $175,000, right? Okay. So let's. And then what about the x-axis? So what would make sense in terms of zooming? Like what would make sense to observe in the x-axis? Should I zoom in or out? Zoom in. So what are a typical number of payments in the loan? Do you guys know?
A lot.
A lot. 1,000? 2,000? That's a lot. What's the standard loan? You know what a standard loan is? In months? 30-year?
300.
360. 360 is kind of the standard 30-year mortgage. And then there's also 20 and 15 years, so that'd be 240 payments, 180 payments for 15 year. So really what makes sense to look at here is not these low values. Where's 360? This is interesting. Oh, shoot. So it's interesting because to show what's happening around 1, 2, 3, or 4 payments, we'd have to kind of zoom in here on the y-axis, but that's not really like what's realistic, right? What's realistic is like around anywhere from 120 to 360 payments. So is that what the scale that I got here? Yeah, so let's zoom in a little bit more on the x. And then let's zoom in on the y, because we don't really care about really what's going on here with very few payments, right? So this is more realistic here. If I could read, I cannot read. There's 180. There's 240, that's 20 year, and then 360 is over here. So this is a good view now. And maybe we want 1 to be less than or equal to x, less than or equal to 360. Okay, now I want to use instead of using the function to graph this, I want to use the formula to graph this. What would I need to do to graph this using the formula? Instead of using the function, right? So Richard used the function. He said y equals f of, you've got these set parameters. X is the number of payments. And the function value is our monthly payment. What about graphing the same graph using the formula? What would that take? What we need to do?
Would you have to say y equals p and t?
Okay.
And then plug in an x for the n?
In this formula?
Mm-hmm.
So if I plugged in the n, is that this the n right here? So what do you guys think? If I plug in x here, and then I do y equals payment, will that graph it? What do you think? Yeah, it actually does work. That does work. That should be red now. Why isn't that red? Oh, because... Oh, that's what this is. There we go. Oh, it's a terrible color for the screen. I'll do red now. There we go. All right, what do you think about that? So... Or you'd have to do y equals this whole thing. And that's actually a little bit better. But the reason I'm showing this is because it's not as convenient as function notation, right? For graphing. So we were talking about reasons for function notation, and we saw that just for calculating values, it was much more convenient to use the function notation, and it shows you all the information, and then it just represents that value without having to have this big bulky formula that you're trying to move around and use in different places. Okay, graphing is another reason why function notation is really convenient. All right, so what would you rather do? Would you rather, just have this nice compact notation that you can just put an x where you want to be variable, and set it equal to y to be the independent or the dependent variable on the y-axis? Or do you want to graph a big formula like this? Okay, so any questions on the homework? So like as we went through this and I was limiting the domain, adjusting the graph window, that was also what you were doing in the homework. Any questions about that? That was the same kind of exercise, but a different, right? So any questions about that? Okay, so let's see, very good. So let's do while we're talking about functions and the advantage of function notation, let's do the box cost problem activity. So that was one of the things I posted on Canvas. Did I tell you guys to get that?
Yeah.
I mean, the guys?
Yeah.
The guys? Let's see.
Yes.
So that looks like this when you open that up. So the cost of materials, everyone have it open? You looking at it? So the cost of materials in dollars for a certain rectangular box with dimensions L feet, W feet is base dimensions, right? So this is base dimensions. Cost is 4LW plus 28 over L plus 96 over W. Okay, and so we want to consider these boxes. So here's a use of GC that's really like as a teaching tool. You can create an activity for students where you put the questions in text and then you have them either analyze math lines or create math lines. Okay, and so as in my time at ASU, I've built many of these. Okay, so and this is nice because everyone has the full assignment in front of them, and then everyone fills in their blank template, and then you get immediate feedback with the responses that you get from GC, and then you can analyze those, right? So this is an example of that. It's a really good teaching tool. And then this box cost problem, it really tries to motivate, again, the use of function notation. All right, so what does the following expression represent and compute? So here's a long, complicated expression. Does anybody recognize what that is computing? That's 708.442.
The total cost of all 3 boxes.
Okay, so he said the total cost of all 3 boxes. And when you say all 3 boxes, what do you mean? Total cost?
Of the total costs of box 2 and box 3.
Okay. All right, yeah. So then, if you were doing this and I was having you submit this for a grade, so you would answer to question 1, you'd put the text in. So this is the total cost, and let's get this total cost of what? I think we can do a little better than the total cost of all 3 boxes. What exactly is this the total cost of? So doing what? And how many of each box? So total cost of all three boxes kind of sounds like maybe we're buying them. And how many boxes are we buying? So can we kind of tighten up the, be more specific here? What's that? See. The cost of materials. Okay, so the total cost of materials for
the rectangular boxes 1, 2, and 3.
okay, but how many? What's that?
So like for 1, 5,
One of each box, right? One of each box, right? So the total cost of materials for one of each of the three boxes. So we were all thinking that, but expressing it precisely is important. Okay? We were all thinking that exact thing, but let's express it precisely. Okay, so I want you to let's just. Okay, so I put up a new. You guys still there? Okay, I put up a new expression. Any questions on? Let's do this. Let's do this last one. So, what's the change in cost of the number 3 type box if its length was increased by 5 feet? Did you guys get that up here? Tell me.
You said B of 15, 7.25, and then minus B of 10, 7.25.
B of
10, 7.25.
7 point. Does everyone agree with that? Let me make mine. What just happened? Got worse. I am flailing here.
Your function equation for B of W is 96 divided by W.
Oh. Is that why you were
Getting on our numbers, yeah.
worried there? Is that better?
Yeah.
Now does it work?
Yeah.
You guys agree with that?
Yeah.
Richard and Angel, you guys agree?
Yeah.
Okay, good. So now I came up with a new question here. What is represented by this expression? I want you to talk with your pairs. 40 times B 6.4 plus 65 times B 16.4. Oh, sorry, that should have been 8.4. There we go. So 40B 8.4 plus 65B 16.4 over 105. What does the number 256 mean? What does that mean? Guys, talk about that. Okay. So she said you had 40 of box 1 and then 65, the materials for 65 of a box 1 with twice the length. And then if you spend all the money to buy all the materials for those, then this would be your average cost per box.
Yeah.
You guys like it? Ashley, you like it? Not sure? What's that? You think it's funny? Okay. Sarah, you agree with that?
Yeah.
Okay. Yep. So again, motivating the use of function notation, right? So you can create these very useful quantities in a situation, and you don't have to use the formula, right? You can just use the function notation, right? Any comments, questions? Do you like this activity for students to help them with function notation? Yeah, and I think both kinds of questions are good. Like, write the expression using function notation for this, right? And then the flip side is like what I did. Here's an expression. Figure out what it means, right? Figure out what it means in terms of the boxes. So both kinds of questions are really good. All right, questions, comments, Richard, Angel, what do you guys think?
Makes sense.
Anything to add? Any questions? All right, we got 15 minutes. Good. So let's do the other one, coordinate point activity. So on this one, I have my own version, and I'm going to be using it like as a didactic object on the screen, and then you're going to work through the activity and kind of be replicating what you see on my version. Okay? So go ahead and open that up. Okay, so here's the first thing for you. So the first thing to do is to, does it say, do you have that text line there that says fixed points? And I'm showing you some fixed points, and I want you to make yours look like mine. Okay, so use the next three, the first three under fixed points, use those math lines to make your graph look like mine. Do you remember how to do that? So how do we plot a point in GC? Do you remember? No? Do you remember?
Is it like the math vector thing?
You the 2 vector, and that's, yeah, control 2, right? Control 2. So never forget that. That's going to be really important. If you want to plot a point, in R2, it's control 2. In R3, it's control 3. And yeah, the math menu, you can find that in the math menu. That's called a 2 vector or a 3 vector, so you want a 2 vector. And actually, the homework for Thursday is going to be another activity that's going to remind you of all these things, right? So it's going to remind you, give you more practice. Okay, here we go. So everyone good? Everyone got the show up the way? You get those 3 points? Okay, next thing is I want you to, I don't want you to use a function. I just want you to use an equation. I want you to use an equation, not a function, and make your graph look like mine in the next line there. So it says portion of the curve shown. In that next line after portion of the curve shown, type something in without using a function that makes yours look just like mine. Angel and Richard, you guys doing okay?
Yes, sir.
Okay. If you have questions, you just audibly speak out. It's fine. So I'm showing you a curve through those 3 points. I only want part of it there, starting from a half to 10. Angel and Richard, were you guys able to get it?
Yes.
Yeah.
Okay. So we're just... Okay, the next thing is, we talked about a little bit about sliders. So using n, if you use lowercase n, this thing down here, the slider opens up. And so I want you to write, does it say, is there a text line that says like movable point or something like that? What does it say?
Plot the movable point.
Plot the movable point. In the math line below, plot the movable point, to write a command line that will do that very thing. So, and then if you push play on n, the movable point will trace points on your curve. So plot the movable point using the slider value n. If you're still working on the, make sure you get the graph first before you start working on that. So plot the movable point. That's a good note right there. That's a good note. Okay, Richard and Angel, do you guys get it?
Is ours supposed to be like yours, where it starts at 0, 0, or is it supposed to
Yeah,
be?
that's, I guess, it's less important. To change that, if you click on N,
Yeah.
then you can. That's how you change this, the values you want to
Oh,
show for N.
Do you want us to also have
So
250
you can change.
steps?
It does just as long as you understand it, and if you want to change it to something else, you could actually only do the points shown on the curve. You could change it here, or if you want to do it just like mine, then you'd have 0 to 10. So whatever.
Got it.
Okay, so, and now actually in my file, there's something else going on here. If I turn off my axes, so if you go to graph, you can turn on and off the axes on the graph paper. The graph paper would be the light blue grid. You see the light blue grid? Maybe not on the computer screen, but on your own. You can get rid of the light blue graph paper, or you can get rid of the axes. So when I take the axes away, there's actually something else going on here. And you have 2 more command lines at the bottom, and I want you to make yours look like mine. So on the x-axis, I have a dynamic blue segment, and on the y-axis, I have a dynamic red segment, which is corresponding to the movable points. So now, you want to think of those as a hint. You want to think of those as sets of points, just like the pink curve was a set of points, right? You wrote a relationship of y and x that gave you the set of pink points, right? Same thing here. So what, you want relationships of y and or x, first of all, that give you the set of blue points. And then you want a relationship of y and or x that gives you the set of red points. See if you can do it. Can you make yours look like mine? Angel or Richard, you guys have it?
Not yet.
Okay. So again, my hint is, say that blue, what defines those set of points? What defines that set of blue points in terms of x and or y, right? Let's talk about the blue bar. What defines the set of points on the blue bar? What defines the set of points on the blue bar in terms of y and or x? She wants y equals 0. Is that what defines those points? All those points have in common that y equals 0. Agree? Yep, that's right. Okay, but now what's left? So the y equals 0 part is like the y equals square root of x part for the curve, right? And then what's left? If we just graph y equals 0, what do you see? All lines are straight. How is it different than what we're seeing here? If you just graph y equals 0, what would be different about what we have?
There is like the moving point.
Okay.
It doesn't grow.
What does it do? Does it shrink?
No, it stays.
What stays?
It only shows the whole line. not the
Everything,
portion.
right? From negative infinity to positive infinity. So what do we want to show? From?
0 to n.
You good at that? See, it's just about,
I got
you
it.
guys can do it, you just got to ask yourself the right questions, right? I just asked you questions. Anyone have it yet? Did you get it?
How do you make it go in one direction?
What's that, Richard?
How do you make the line go in one direction? Mine keeps going, oscillating back and forward. Or like when the slider keeps oscillating
So
back
it's
and
not
forth.
about, so it's about the mathematics of the line itself. It's not about how do you make it do something, right? So,
Oh, I have the line. I just want to make it go in one direction.
but it's not.
I know, that's not the main thing.
Yeah, the main thing is
Yes.
like, okay, so if I pause n here, what do I have?
Yes.
Which points do I have? So y equals 0. All those points are y equals 0, but I don't have the whole x-axis, right? I don't have.
Mhm.
What do I have instead?
The domain for the x from 0 to n.
Yeah, that's it. and then I think once you get the x, the y is simple. Right? Does it work, Sarah? Yeah. So it's all about the mathematics, right? It's all about getting in the mentality of it's a set of points. What set of points is it, right? What set of points is that blue bar, and what set of points is the red bar? That's the mentality we want to be in, and that's how you can come up with it. So, Angel, did you get the red bar?
I got the blue one. I'm working on the red one right now.
Can you do it on the fly? Can you tell me what it'll be?
The red one?
Yeah.
X equals 0,
Okay.
where y is between 0 and n.
Okay. What do we think? Is it x equals 0 when y is between 0 and n? Elizabeth. So is it 0, is a y from 0 to n, or something else? Is that y coordinate n? Are you guys still there? Am I still here?
We're still there.
Okay, good.
We
So
can hear you.
is that from 0 to n, Angel? Is that n?
No.
Instead? Oh, we're way over, sorry. So what's defining that highest y value is the y value of your point, right?
Yeah.
Okay, any questions? Okay, so we're over time. I was going to show you a demonstration of the final products of the activity you'll do for Thursday. So it'll be a homework for Thursday. It's a 4-page activity that's much like this one. Okay, it's going to take you through some questions about function notation and sliders and points. And then by the end, you'll create this animation around this football temperature outside and attendance at a football game. So I'll post a video that shows you what the final product looks like. And then you'll have the 4-page activity, and you just work through it step by step. It holds your hand the whole way. So just read carefully, and that'll be the Thursday. Any questions? Was everyone able to get the finished product here? Did you guys both get it, Richard and Angel? Okay. So yeah, look for it's called the temperature attendance points and sliders, TAPS, TAPS, temperature attendance points and sliders. What's that?
It's already posted.
It's not. Oh, it is already posted?
The tax is already posted.
TAPS is published?
I
Shouldn't-
thought we did it for today.
No, let's do Thursday. It's already published.
Oh, I must have done that last Thursday. I forgot I did that.
Yeah, you're good.
Okay.
It's already published.
All right, there it is. So,
I was like, I already worked on it.
oh, you did? You worked on it. Fabulous. Okay, good.
Yeah, it's good. The video I think is up too.
And the video's up too.
I think, yeah.
I'm just better than I think.
You know.
Okay, have a great day, you guys. See you Thursday.